Okay, in lesson 1.4 here we're going to talk about complex numbers, and probably what will remind you here of what a complex number is to first start off with an imaginary number, because part of a complex number is an imaginary number. So let's go back here and talk about our number system. Of course, we have the set of real numbers and we have the set of imaginary numbers. And so the two sets combined here to give me complex numbers. Okay, so really what a complex number is a combination of a real number and an imaginary number. So the form of a complex number is a plus bi. Okay, you may remember that from last year possibly. So a is the real part, and then b obviously here is the imaginary part. Okay, so you can kind of remember, look at a little cartoon here. We get imaginary numbers from taking even roots of negative numbers. So let me look at just a little bit of a review where imaginary numbers come from. Okay, so remember, taking the square root here of -1 gives me the imaginary number I. So that's where we get imaginary numbers from. Now, let's take this and we're going to need to sort of expand on something so we can evaluate. So let's say that we need to know what the value of I squared is. So what I'm going to do to get the value of I squared is I'm going to take this equation here and just square both sides. Okay, and so that'll give me I squared. So what we arrive at here is that I squared will be -1, because the square root of -1 squared is just going to undo the radical. It's not really going to square the negative. So this is important for a lot of the evaluating that we will be doing here. Okay, now as far as, I think that's all I had about imaginary numbers to review you with. We may come up on something here that I may be leaving out that I may have to come back to that. Okay, really easy problem here. It says write the expression in the standard form of a plus bi. So they want me to write it in a complex form here. Remember, this is the real part and the imaginary part. And all we really have to do in this problem is combine like terms. So we have 8 and 6 here would give me 14, and then -5i plus 4i would be -i. Okay, so real simple. Now, just to be sure of something here, let's look at this same problem but in subtraction. So let me write the same thing down here, 8 minus 5i. Okay, now let's say if we had to subtract the two complex numbers, 6 plus 4i. Now what we have to do in subtraction, that's a little different there, is we have to distribute that negative sign if this was subtraction. So I would just basically drop the parentheses off, and now this would be minus 6 minus 4i. Okay, there again, that's distributing that negative sign there now. So then we could say 8 minus 6 would be 2, and -4i minus, -5i minus 4i would be -9i. Okay, real simple there. Now, in the next one here, we're going to multiply two complex numbers. So really, we're just really treating I pretty much like a variable. And so basically we can just use the FOIL method right here. So first, -9 times 9 would give us -81. -9 times I would be -9i. And 2i times 9 would be 18i. And then 2i times I would be positive 2i squared. Okay, now we're going to clean this up a little bit. And let's recall here what I'd said earlier about I squared. I squared is really here just -1. we're going to make that substitution. We're also going to combine those two like terms. So now this is going to give me negative 81, negative 9i, and 8i would be a positive 9i. And if we substitute right here, I squared, if we substitute negative 1, 2 times negative 1 would be negative 2. And now finally we can put negative 81 and negative 2 together and get negative 83. So negative 83 plus 9i. Okay, now this is a slide that you really need to pay attention to. Be sure that you take notes of this example. Okay, this is actually something that none of you have probably seen here, and that's to simplify an expression like this. Well, when you look at this, you probably say, well, there's really nothing to simplify, because we should know that we can't cancel out those i's. But the problem with this expression being simplified is, recall here that remember this, I is the equivalent of the square root of negative 1. So what it's like here is, it's like that we have a radical in the denominator. So what we're doing, even though we don't see a radical, it's really a radical, and we have to rationalize it. Now recall, when we rationalize here with an expression down here, it's not enough to say just multiply by I over I. Okay? But when we have an expression like this that we have to rationalize, because recall that is a radical, what we have to multiply is by the conjugate. So I'm going to multiply the numerator and the denominator by the conjugate. Now really what I want to do is multiply the denominator by the conjugate to get rid of the imaginary numbers down there. Now, since I multiply the bottom, I have to multiply by the top. And really here, what we're multiplying by is a fancy 1 that's going to get rid of this eventually for me. Now, recall, let me move this out of the way, when we multiply by conjugates here, that we don't have to really use the full method. We can just use first, okay, and then last. Okay, now let's multiply this first. So 3 times 3 here is going to give me 9. It's always a positive times a negative with a conjugate, so it's always minus. And I times I is I squared. Okay, now in the numerator, I just have to multiply by 3 minus I, but I have to be sure to distribute here. Okay, and multiply both terms. So 20i times 3 is 60i. And then 20i times negative I would be negative 20i squared. Now you notice we still have the imaginary number in the denominator, but recall we can substitute for I squared here, we can substitute negative 1. Okay? So this would really be 9 minus a negative 1, which would really be 9 plus 1, which is going to give me 10. Okay, in my numerator, again, we're going to substitute negative 1 in place of I squared. And so negative 20 times negative 1 would be positive 20. So we can change this to 60i plus 20. Now, we can reduce this, even though this operation is 20, we can reduce this because we can reduce each number here by 10. So if I reduce everything by 10 here, this would give me 6i plus, and then reducing that by 10 would be 2. Of course, we wouldn't have to write over 1. Okay, so this is definitely a problem that we're not used to seeing, and you may want to look at the example before you actually do this problem. Okay, now this problem is actually just really easy. It says perform the indicated operation and write the results in standard form. Okay, so we should know here, we're taking the square roots of negative numbers. They're nice perfect squares. They're going to be imaginary. So square root of negative 36 here would be 6i. And then the square root of negative 16 would be 4i. Okay, and now I can simplify this to say 6i minus 4i would be 2i. It's a real simple problem there. Now perform the indicated operation. What they're really getting you ready here for in this problem is for the quadratic formula. So that's probably something we'd end up with a quadratic formula. And what we'll have to do here is simplify square root of 45. So I can simplify the square root of 45 with negative 5 times 5. So that's going to simplify here with that negative 9 to 3i square root of 5. So negative 8 minus 3i square root of 5 over 48. Okay, now what this college algebra book is different about here is we've been usually taught in Algebra 2 that when we reduce this, we have to reduce all these numbers, all three of these, by the same thing. And so really nothing's going to go into negative 8 or 3 or 48. But we know we can't really cancel 8 and 48 because the operation there is not multiplication. So what this text expects us to do here is that when we can't reduce all three numbers, what it likes to see, I'm pretty sure about this, is it wants you to split it up to reduce it. Okay, so by splitting up, we mean this. We're going to take these individually here, this, the negative 8, and then the 3i square root of 5, and individually put them over 48 like this. So negative 8 over 48 minus 3i square root of 5 over 48. And so now if I split them up, I can actually reduce them. So negative 8 over 48 here would reduce to negative 1/6. And then 3 over 48, 3 is going to go into 48 16 times. So this will give me, forgot, we're going to reduce the 3. So it would just leave me with I square root of 5 over 16. Okay, so used to in a lower level course like Algebra 2, it's acceptable to leave this. But in a college algebra course, if you notice that you can reduce these like 3 over 48 or 8 over 48, and it didn't have to be both, it could have just been one, then you're expected to know that you have to split those up to reduce those. And that's all of 1/4. Again, be sure when you do this problem here where you have to simplify by multiplying by the conjugate, be sure that you look at an example of this before you do this. And when you get to this problem, you may need some help. We may do an additional example of this in class for you.